In engineering, you cannot go alone in any field because you always need the support, coordination, and the assistance of all the other disciplines. So thank you very much for giving me this opportunity. And today I will try to briefly discuss what building services are and how it can interact with the structure, and as a building services designs engineer, what problems we have had and how we have tried to overcome these issues. Okay, we all know what a building is, but why do we need building services in a building? Buildings are used for so many different purposes, and depending on the use of the building, we will need different types of services. Building services are required to make the building functional and habitable. It is also required to make the building safe for the occupants. It is also required to make the building environment comfortable for the occupants. Now, the level of building services or the amount of building services what one requires in a building varies depending on the purpose for which the building is going to be used. All buildings will not have the same set of building services, but there will be certain very common building services which are literally found in all buildings. For example, electricity. But the other services will vary depending on the use of the building. Let me quickly list out some of the building services which are found in a building. These are some of the major ones. Electricity, which we all are familiar with. Water supply, which will include hot and cold water. Wastewater and sewer disposal. Ventilation and air conditioning, they very often go hand in hand. Fire detection and fire protection, that also very often goes hand in hand because they are all done by the same contractor. Then we also have the telephone systems, TV, data, surveillance, security. All of these we call ELV or extra low voltage systems. That's another group. Then we also have lightning protection, which basically will protect the building irrespective of what the application is against direct light. So all these services have a specific task to perform, and they have a role to play in making the building habitable, building safe, and building comfortable for the occupants. In addition to the services connected with the building, we also have some of the other systems which will be found normally in a building. Our sponsor today is involved in the first two, or maybe the three: raw water treatment, wastewater treatment, and solid waste disposal. And also we will have stormwater disposal or collection. So all these come under building services. Now, before we go further, it is important for all of us to understand how the services are designed. I mean, if somebody asks you how are the structure of a building is designed, I'm sure you all will have a very, very clear, specific, and explicit answer. But looking at the building services, you would understand it is not one discipline that we are talking about. It is a mix of so many different disciplines. And very often, you need different sets of people to attend to these different systems. So it is good for us to know how the services are designed in the building. It may be designed by independent consultants who are specialists in different disciplines, which very often is the case because people who are experts in electrical engineering may need not necessarily be competent in designing a plumbing system or an air conditioning system or any other system for that matter. So generally, the specialists will take over different disciplines and design those disciplines. But this can have complications because if there are 4 engineers or 4 consultants designing different systems, more often than not, they will be doing the designs at different stages. And they would possibly be literally working in watertight compartments. And then all these systems will have to go into one building. We will be discussing that in a short while, which we call coordination. So if the building services are designed by different consultants, there could very well be a possibility of issues and problems which crop up in the coordination. So we have another alternative which is praxis. That is, all the building services are designed by a team of consultants working together on all disciplines. It can be a company, a consultancy firm, where different personnel are employed or hired on assignment basis who have the know-how and the knowledge on different designs, but they all work together. They talk to each other, they communicate with each other, and more than anything else, they share the design concepts with each other. So coordination starts to take place from that point onwards. There is another system which have been tried a few times, which is the design and build process. Design and build process is very common in civil engineering, and correct me if I'm wrong, sometimes in structural engineering as well. I don't know how prevalent that approach is with respect to the structural design, but maybe there are situations where design and build process is used. Design and build process have been tried with building services, but I'm afraid it has not been tremendously successful. So we have very few companies who are doing design and build for total building services. There might be situations where there is design and build process being used for certain services, but that is also an option. Before we start designing the building services, we as building services engineers now talking, there are certain essential information which is required for us to commence the building services design. What are these? First of all, we need what is called the client's brief. The client is the person who's building the building. He obviously is building this building for a specific purpose, or he has a specific purpose in mind. So he is the best person to advise all the design engineers what this building is going to be used for and what is expected to be made available in the building. We call it the client's brief. Sometimes this client's brief is very, very difficult to get. They will say, no, we need the services, you please design all the services that I need. But if the brief is not very clear, we run into difficulties halfway down the design process. We'll come to that a little later. And for us to start the design process, we must have the architectural drawings. Because without the architectural drawings, building services design just simply cannot start. You can, of course, with the schematic drawings, you can discuss the design concepts, which are very important. We can do the design concept reports and obtain concurrence with the client and even the other stakeholders, other designers of other disciplines. But to do the design per se, we must have the architectural drawing. Then we also need the information on available infrastructure services. Basically, what are they? Whether there is power supplies available in the area or the location where the building is being constructed, whether there is pipe-borne water in that area, whether there is a centralized sewer treatment system like in the Colombo municipality or some of the other municipalities found outstations, and so on and so forth. This information is very important because some of your designs will have to be carried out keeping in mind the infrastructure available. For example, if it is a very, very remote area where at the moment there is no power supply, then what do? We have two options. We may have to run a very long service line in consultation with the electricity service supplier, or provide generator supplies. In Sri Lanka, it's not very common, but there are other countries where, like in the Maldives, where the entire electricity supply is dependent on generators. So that is why I said infrastructure services available are important. Then, any other requirements stipulated by the local authorities. Local authorities also have their requirements, and they are, when you apply for building permit or planning approval, they come up with all kinds of regulations. Particularly, this applies to fire systems. It varies widely from area to area, authority to authority, and client to client, and also the end use of the building. Then there is another factor we need to consider when we are talking of designing building services. Details of any certification expected to be obtained and the relevant standards and requirements. This is very, very important because certain buildings have the need to be designed conforming to certain international standards. Some of the clients, particularly say in the hospitality industry, they have their own standards, safety standards and other standards. So the services will have to comply with those standards as well. Then there are certain industries which will want or require international certifications such as Green Building Certificate, BREEAM certification from UK, so on and so forth. So it is very important that we know the requirements before the design is started, because if the design is carried out, then it is generally carried out according to the Sri Lankan requirements and the available standards, because there are no standards for every single service. So, I mean, there are some standards available. So we tend to use those standards, and for the rest, we use international standards like the BSCA or British standards in most cases. But if a specific standard like LEED certification or green building certification is required, we need to know that upfront so that our designs can incorporate all the requirements which are necessary to obtain the certification. The next question I would like to pose is, when should the building services design commence? Unfortunately, I have been involved in quite a large number of buildings where the design phase of the building services commenced rather late in the day. All the architectural designs have been finalized, planning approvals obtained, so it is frozen. Sometimes even the structural design is complete. They're ready to start construction, then they think of the building service and say, here is a building, do the building service. Now, that is not how it should happen. The design of building services preferably must start at the conceptual design stage. Because if we do start at the conceptual design stage, it makes life easy for all stakeholders. It makes life easy for the architect. It makes life easy for the building services engineer. It makes life easy for the structural engineer. Three main parties involved in the building design. Because each one of them have their own requirements, which need not necessarily meet with the other person's requirement. But if you do come in together at the conceptual stage and have a constant dialogue, you understand each other's requirements, and whoever is responsible can make the necessary allocations to accommodate those requirements. If it can't be started at the design stage, it must at least start when the architectural drawings are prepared. That is an absolute must, because if the architectural drawings are frozen without the involvement of the design, building services designs engineer, particularly in complicated or complex buildings such as hospitals, hotels, uh, large office complexes, high-rise apartment buildings, services coordination becomes critical. So we must at least start when the architectural drawings are being prepared. Then, at the beginning also I mentioned this, coordination of all services. Now, when we talk of coordination, there are a number of different coordinations which need to take place. That I think is very peculiar to building services. Other disciplines, say structural, will have to coordinate with the civil or architecture architect. But building services, not only they'll have to coordinate with the architect, not only they'll have to coordinate with the civil engineer, not only they'll have to coordinate with the structural engineer, who are the other key figures, they have to coordinate among themselves. Among the different services also they have to coordinate. So it becomes a fairly complicated, involved process. So having said that, if I ask you, is it real necessary? I'm sure you will agree that it is an absolute necessity. Because coordination is very complex. It has to coordinate between the different disciplines in the building services itself, other stakeholders like the civil engineers, architects, structural engineers. So coordination is absolutely necessary and essential. Earlier you start coordinating, the better it is for everybody involved. So if that is so important and critical, we need to know who is responsible for the coordinated drawings. As I said at the beginning, with so many different disciplines being involved in the building services, there will be so many different people responsible for the design. But coordination has to take place, and what we call in the building services jargon, a coordinated building services drawing has to be done. So who should be responsible for coordinated drawings? Coordination of M&E services is extremely important. We discussed that. We also discussed that a constant dialogue is needed at the initial stages. Among the other stakeholders like the civil engineers, architects, structural engineers, definitely between these three parties and the client. A constant dialogue is needed at the initial stage that will make the whole system work better. And we will all be able to take mutually acceptable decisions being taken if we follow this simple steps. We are now fortunate that we have sophisticated software which can do this coordination pretty well. Software like Revit. It's extremely useful for complex buildings, large high-rise buildings, but unfortunately for a small country like ours, it is still out of reach because they are very expensive. Not only that, unfortunately, even though it's very unfortunate, but the reality is the large projects which are handled in Sri Lanka are handled by foreign consultants. Very often with no participation of Sri Lankan engineers or consultants. Sometimes participation of the Sri Lankan engineers is confined to a rubber stamp and putting a signature, which is a very, very sad state of affairs. So software programs like Revit is still not very commonly used in the country, but there are some drafting companies who have invested in the Revit software and they can do a coordinated drawing using the Revit software, which literally is a 3D drawing, which is absolutely fantastic for coordination of all the services. Now, having said that, all services do not necessarily have a great interaction with the structure. Let me list out the three main services which have a fairly great or large interaction with the structure. I'm sure you will agree with the first one because they are the ones who cause you most of the problems as structural engineers. Sometimes we come and ask to have a sleeve or an opening put in the middle of a beam or somewhere in the beam because your structure is already done. We say, sorry, we can't take the pipes. So we all have our issues, but plumbing definitely has a major interaction with the structure. The second discipline, air conditioning, also has equally great interaction with the structure. And electrical to a much lesser extent, but it still also has some interaction. Then other systems like fire, for example, fire protection, like sprinkler systems, if it is used in a building, yes, the structure has some interaction with the sprinkler design, but if it can be coordinated at the very early stages, not that it can't be carried out without this coordination, but if it can be coordinated at the early stages, the systems becomes very acceptable and simple. And at the end of the day, it looks pretty good. So let us now talk about some of these major three disciplines because we have only 1 hour. So let's see what are the problems we encounter and how we can overcome these issues. The problems encountered with plumbing, service shafts and rises, particularly in high-rise buildings. When I say high-rise, I'm not really referring to the high-rise which is 10 stories and over, even medium-rise buildings. service shafts and risers are absolutely necessary, essential, and let us understand why these service shafts and risers are provided. It is basically to bring all the services from ground level upwards, as well as bringing the certain services like sewer and wastewater from every single floor down to the ground. So it's a two-way shaft. Some services can travel upwards, some services will travel downwards. Now, if the service shaft and the riser is for this purpose, it is obvious that these risers will have continuity. They will be in one straight line going. But sad to say, we have come across buildings. At every floor, there are risers, but they are not necessarily in the same place. So when we say you must have risers, yes, we have provided risers, but they are in different places. So that is why I said coordination of the designers at the initial stage is critical, so that then we can say, sorry, no, you can have a riser in every floor, but they have to also be vertically aligned. We also run into difficulties in the internal sewer and wastewater piping or the toilets. Toilet may be a very small entity, which will basically have either one or two wash basins if it is in a hotel room, a bathtub, a shower cubicle, and a WC. These are pretty standard fittings and fixtures which are found in the toilet. So why should it become such a problem? Because all these things have to get connected to a wastewater and sewer piping system, which in turn will have to get connected to the risers, which will take them down. And also we will have to have cold water supply and hot water supply coming into the toilet, which needs to get connected to most of these fixtures and fittings. So they are fairly involved and needs careful planning. Then we also have, after all these services are taken down, like the wastewater and the sewer, there will be what we call the horizontal main pipes at the ground level. Sometimes it need not be at the ground level, it can be at a service floor level, which may be where the car park flows start. It's not an issue. It can be either at ground level or any other. Now, this is a typical toilet layout drawing we received from as an architectural drawing indicating a service shaft. This makes us feel very happy. Look at the size of the service shaft. Look at the location. Pretty good. We have enough access for maintenance. Positioning is really nice. So we say very happy, and we are asked to start designing the building services for all these toilets. Toilets can be typical or it can be atypical, but basically if it is a high-rise building, you will have a toilet, and very close to it, you will have or adjacent to it, you will have a service shaft. So when we are in the middle of our design, we get a bit of a shocker. We get the structural layout also made available to us very kindly while we have already commenced our design. Then there's a bit of problem happening here. In that clean space of the service shaft, we are now seeing some obstruction, which is the structural beam. Obviously, we should have anticipated that to be there because we are seeing through walls and columns. But sometimes we also don't start thinking too much about, because as long as we have a drawing to work on, we are quite comfortable doing it. But when this happens, it causes major problems to the design, and we have to make sometimes drastic changes. So it is very important. That's why I said, if we were involved with the structural engineer at the very beginning, he would say, excuse me, yes, you have a service duct here, but I have my structural beam going across. Fine. We can't stop that from happening. But knowing that fact will help us design the systems better without running into difficulties later on. So having had a beam in the middle will make the design different. Then how do we design the internal plumbing? There are two ways. One is the conventional way. The conventional way is the pipes puncture the slab at all these different outlets, go through the slab, and the connections are laid below the slab, which used to be what we always did long years ago and continues to be done even now. You make a hole in the slab, and of course we take precautions and seal them properly, but it just goes down and then connected up. In apartments or even in hotel rooms, this could be a problem, because in condominium apartments, what is the boundary? If it is a house, we have the boundary, which is the boundary of our land. In a condominium, what is the boundary? Floor of your apartment, peripheral walls, and the soffit above. That is your boundary. Now, if we puncture the slab and take the pipes down, what are we doing? We are literally laying our sewer pipes, wastewater pipes, cold water supply pipes in somebody else's property. This is common even in some of the big apartment complexes which have been built in this country. Condominium authority also turns a blind eye and allows this to go through, which I am appalled, because you are having all your wastewater lines in the apartment of the occupier below, who has nothing to do with you. If you have a leak or a blockage, who suffers? Not you. Then numerous openings in the slab can and will lead to water leaks, which is actually a disaster in some of the buildings. Because if you start having water leaks, sealing them up later is going to be one hell of a task. Once you have all these pipes coming down, you can't leave them like that. I will show you a picture just in a short pipe. It looks really ghastly. So you need a sealing to conceal all the seals. And once you put a sealing, access for maintenance will become another problem. Then also, once you puncture the slab and go down, it has to travel horizontally up to the closest service duct. You may have structural beams on your path. Then the pipes will have to drop further so that the pipes can run below the structural beams. So a fairly large gap may be necessary when you try to do that. This is what the conventional plumbing system looks like. Not a pretty sight, isn't it? Because these are building survey engineers get blasted when we come up with this kind of design, which I personally do not agree with, because there are options, alternatives. Okay. How much time do I have? How much more time do I have?
You can continue, sir.
Thank you very much. Okay. Is there an alternative? There has to be no. because as we all know, every problem has what? Has a solution. So this also must have a solution. No, this can't be a problem without a solution. Only thing we need to find out how. Yes, there is a solution. We as building services engineers say, can we please drop the toilet slab by approximately 150 millimeters? This may be with the connected beams or not necessarily with the connected beams if the beams are on the periphery of the toilet other than at the service duct. Now, I'm very happy to say where we have been involved in the building services design at the very inception. And whenever I have made this request to the structural engineer, I have never had no for an answer. They have always said yes, if you tell us where, we will do that. But you have to tell us where we need. Sometimes it need not necessarily be within the confines of the toilet, but they have always agreed, which I'm very happy because wherever we did this, we have had very, very good systems which are working pretty well. Once you drop the slab, we can waterproof the structural slab, which is very important because we do not want any leakage or seepage happening through the slab, which will be very unsightly from the unit below. First, we waterproof the slab, and on the slab, we lay all the pipes above the structural slab, which is dropped by 150 millimeters or so, and lay the pipes above that and direct it to the riser. The pipe design essentially must have another feature which we call clean out facilities, because the piping system we are going to install in this toilet is not going to be accessible from bottom, nor will it be accessible all over the place from the top. Therefore, it is very important that we think of future maintenance when we are designing this system and provide adequate facility for maintenance, particularly in the sewer and wastewater systems, to clean out in the most unlikely case of having a blockage. Because if you design your system correctly, believe me, you will not have blockages. Then there is a cavity because it's a 150 millimeter drop. So what do? Most often we have filled it up with very lightweight material like polystyrene pebbles, or I'm sure you gentlemen who are in the audience can come up with all kinds of solutions. And then a very thin layer of concrete is laid on top of this infill, and that slab is also waterproof. So we have now two waterproofing surfaces. Once you waterproof the top slab, you finish it off with tiles. Now your entire plumbing has become invisible. But there are clean out facilities built in which are accessible from the toilet itself, so that there is no breaking and making and things like this. Then it gets directed to the service shaft and to the risers. This will result in the underside of the toilet slab is very clean and neat and free of any leakage. In domestic applications, in many cases, or even in apartment complexes, you could do away with the additional cost of a ceiling which is needed to hide all the sins what we discussed a little while ago. Right. I'm just sharing the same example what I used. I'm sharing how we handle the different services. Is this drawing clear enough? These are the drawing for sewer. If I'm to, sorry, if I'm to show, this is where the riser is, the sewer riser. And below that, or here, we have the vent pipe. There will be two toilets on either side. I have shown only one, the other one is a mirror image. So the sewer pipe from the WC comes as straight as possible to the riser. That is a essential criteria we always use. And from the other side also, it tries to come straight to the riser, but we have a structural beam which we are aware of. So what we do is we put a 45-degree bend, drop it down, go below the beam and connect to the riser lower down. Absolutely no problem. It works pretty well. So we have overcome the issue of the sewer piping. Now let us see how we handle the wastewater piping. Now wastewater piping becomes a little difficult because of the structural beam. Because wastewater piping needs to have different connections at different levels. So in this case, we have, unfortunately it's not very clear, we have one riser here. There's a second riser for the other toilet wastewater pipe here, but we use a common vent pipe which can be on either side, where the connection is above the floor level, so the beam does not interfere. And we have the clean out points. There is one clean out point provided here, there is one clean out point provided here, and a third point provided here. And if you observe, we are only using 45-degree teeth and 45-degree bends, no 90-degree bends. So through these three or four locations, we can access the entire wastewater piping system right up to the service duct. So no need for breaking and openings to access, because it is done through removable trap on the flow drains which we provide. Okay, then we come to the horizontal main pipes at ground level. Now main pipes are normally taken out at ground level. Once it comes to ground level, it needs to go out of the building because it needs to get connected to either your own wastewater treatment plant or to the municipality sewer main. So these pipes have to come out of the building, and normally they have to come out below the ground beams. Now, if depending on the size of the building, you gentlemen will know how deep the ground beam is, because it will be determined by the structural design. We have absolute no say. So once that happens, which can be around 450 millimeters, correct me if I'm wrong, we need to go deeper by 450 millimeters, and then start our horizontal journey. Okay? This can cause problems, because then you are already starting off with virtually half a meter depth and allowing for the slope, you might come out pretty deep. And if it is a local wastewater system, taking the wastewater and sewer by gravity flow might become a problem, and we may have to put in some sumps and pumps. So we have also once again requested during our initial discussions, there is an alternative. And what is that alternative we have requested? drop the ground beams by about 300 millimeters with respect to the floor side. Once again, I must tell you, I'm extremely happy with the parties whom I have worked. No one has told me, no, it can't be done. They have always obliged, and we have had fantastic working relationships. And more than anything else, it just comes out below the beam, below the slab rod. So we are pretty good because we have saved a lot of depth in the invert levels. When you create a gap between the floor slab and the ground beams, we can take all the horizontal pipes. Not only that, this can also allow us to take the cables, incoming main power cables into the building also, otherwise which could have again required going deep down and trying to come into the building at a much, much lower level. So coordination at the beginning makes life easy for all of us. Then the other system which has a major impact or major interaction with the structure is the AC system, particularly if it is a ducted system. Chill water system with individual fan coil units don't have that much of a problem because all you need is a reasonably sized service shaft where, excuse me, where the main riser pipes can be located. Once we have the riser pipes, all the other branch lines will generally run inside the ceiling, particularly of the toilet. But if you have like an office complex, where you have large air handling units connected to a ducted system distributing conditioned air to the entire office, then the structure comes into the equation. Because we do need adequate space to locate the air distribution ducting. Now, this is where we run into major difficulties because these monsters are not small at all. They're big because there is transporting air. So we need a lot of space. Generally, the depth of these distribution ducts are around 400 to 450 millimeters, or maybe 350 to 450 millimeters, which is quite big when it is the depth between the soffit to the ground below. That's another misconception we have. I said it deliberately, from the soffit to the floor below, because that is what we are told. But it is not so. Architectural drawings always give us a space between the slab and the soffit, and we look at it and say if it is anything more than 3 meters, and if we have about 3.5 to 4 meters slab to slab, we are very happy. We say, that gives us adequate space to look at our ducting. But there's a catch to it. There are beams. There are beams running in both directions, longitudinal and lateral. Then the ducts can't go against the soffit, drop down, wrap around the beams and go up again. No, it can't be done. A pipe may be possible to do. Ducts will have to run straight. So literally what happens is, then the entire ducting system will have to be laid at the bottom of the beam. So the entire space which is occupied by the depth of the beam is wasted. If you are doing a ceiling, then it will have to be 400 to 450 millimeters from the bottom of the beam. Now that's a different proposition which can cause a lot of repairs. Here again, we need to have a very constant dialogue. We know that you must have beams, but we can have a compromise. Maybe we can have deep beams running in one direction, not so deep, secondary beams running in another direction. If we know that and if we discuss it, And together with the architects, we could plan out our ducting system so that majority of the ducts will use the depth advantage of shallow beams and avoid trying to cross the main beam. That is practically possible, but it needs a lot of coordination between the air conditioning consultant, civil engineering or the architectural consultant, and the structural consultant. And once you come to that agreement, definitely the arrangement of the beams can help. I will just share with you one example of how we handle the building. Now, this building has had beams running in both directions, like in this direction as well as in this direction. So since we had the dialogue up front, we all agreed that the main beams will be these, in this where the center lines are indicated. But fortunately, this building had a bit of a cantilevered section because this was constructed in a very restricted space where the column foundations could not be taken to the boundary because the other person has used the space for his building. So there was a bit of a cantilever provided, which was really music in our ears. So we agreed to make use of the cantilevered section of the building to position our main air conditioning distribution duct because we were able to locate our air handling unit in this area. So the large size dimension ducts ran in the cantilevered section where there were no beams. And then we ran branch lines parallel to the deep beams, the main beams, where we could make use of the space difference between the main beams and the secondary beams. All that was done to ensure that the ceiling height was kept to a maximum. And in these buildings, we cannot put the ceiling flush against the main beams because we use the space in between the false ceiling and the soffit as our return planar. So we need a gap between the bottom of the beam and the false ceiling of at least, say, 50 millimeters, minimum 25 millimeters. So these all could be coordinated if we work planning our individual activities from the very beginning. Then we have the electrical system, which is not necessarily as complicated as the plumbing and the air conditioning, but it has something where we had to be extremely careful. Laying of conduits in slabs. Now, this is something where we have run into numerous difficulties because the reinforcements are there in the slab. Often there will be 2 layers. But our requirement of the conduits is on the slab and towards the bottom surface of the slab because the conduits feed the area below the slab. And we have to have conduits laid and the service points or the junction boxes as we call it, or pull boxes, have to be accessible from the opening which we create in the bottom surface of the slab. So we run into difficulties in coordinating with the reinforcements and finding space for the conduits. And one thing I am always insisting, which lots of people disagree with me, but I am insisting that electrical conduits must be treated as water pipes. What do I mean by saying that? Every single joint must be solvent socketed. And The junction boxes and the pipes and the fittings must come from one and the same supplier, same manufacturer. Because if you buy it from different manufacturers, they will never fit in nicely. You cannot use a solvent socket. What is the problem? When we are casting the slab, and particularly when we are vibrating the concrete, these will get shifted or it will jump out of a mechanical joint, which is not solvent socket. Then the grout will creep into the conduit. And what good is a conduit if it is filled up with grout? So we are very particular that all the conduit pipes will have to be solvent socket before and approved by the building service engineer before the slab is cast. Because the contractor say, "Matya oka mokatada concrete වලින් වැහෙනවනේ ඒක කොහෙවත් යන්නේ නැහැ නේ ඕක." But he literally realizes that the problem happens before the concrete sets. So that is where we have to coordinate closely with the structural engineer when we are laying our concrete. And also this is very important if it is on the roof slab, because if there are openings created in the conduit system, rainwater, if it gets in, leaks in, it will travel all over and you are bound to have huge problems of rainwater leakage in the places where you can't imagine why it is leaking there, because it runs through the conduit system. Okay. Then we have few other requirements. I think I should not take too much time. We have few other requirements like the fire water storage, domestic water storage, domestic overhead water storage and booster pump room, and we need to find space for these. This again has certain restrictions. Fire water storage, for example, very often is pretty large. If you have a sprinkler system, it can be as high as 225 cubic meters, which is a large volume. Or if it is a hose reel system, it may be, and a landing wire system, it may be something like 65 cubic meters. So we need to find space for this. Not only that, if it is a sprinkler system, the regulation demands that the fire pump room or the fire pumps have positive suction. So it's not only the water storage tank of the fire system that we need to find space underground or above ground, whichever the case may be, but for the fire pump room also. So these two need to be very carefully discussed and agreed upon with all parties, particularly with the structural consultant. Then the domestic water storage. It can be underground, it can be above ground with a small underground tank, because our municipality water supplies do not have sufficient power to pump up to even 3-4 story buildings, and you are not allowed to directly connect the pump and boost the water flow and pump it through. You have to always have a underground sump into which the service connection will be connected, and then from the sump you need to booster pumps. It can be either at ground level and boost the water supply to all the floors, or better system is have a small booster pump at the rooftop level, which will only be necessary for 2 to 3 floors, the topmost floors, and use the gravity head to boost the pressure of other floors. But these also need to be accommodated. Then all these need to be planned in consultation with the structural engineer. That will facilitate a well-coordinated building with functional services and access for maintenance. Why I'm saying this, why I'm repeating these is all those facilities what I mentioned, the locations are pretty flexible. Other than the main incoming water sump, which has to be at ground level. All the others can be located in any part of the building, depending on where it is most convenient for the rest of the design. It can be on the roof. This entire fire water sump, domestic water sump, fire pump room, domestic pump room can all be on the rooftop. but that has to be coordinated at the beginning. Okay, that has literally brought me to the end of what I plan to talk about, but I'll be very, very happy to answer if you have any specific questions, or even if you disagree with what I have said, why should you do that? Please feel free, because we are among friends. So over to you.
Thank you very much, sir, for that very informative presentation. We will now move on to the discussion session. A kind reminder to all our participants, if you have any questions, you may unmute yourself and you can ask the questions.
It is Mr. Vijita.
Yes.
I have a little concern on the scenario at the ground level. Your presentation, I noticed that ground beams drop around 300 millimeter with respect to the flow slab. I can't understand this scenario because ground beams always supporting the flow slab.
Yeah.
So you mean the ground? So I can't realize this situation.
Yeah. Let me explain. Even though we drop the ground beam by 300 millimeter, it is built up to support the flow slab. It is not hanging in air. It can be built up with a material which can easily be punctured to take the pipes out or the cables in.
Right,
That's how it is.
Right. Specifically, ground beam extended by 300 or some other millimeters to cater your services to go through, is it?
That's right. Because otherwise we will have to ask for, if the ground beams are very thick, it can go down and come out. It is a very cumbersome way of doing it. So this has made life easier.
Yes. Okay. Thank you.
Thank you very much. Okay.
Engineer Vijay Pereira.
Yes, sir.
Yeah, thank you for your very informative and very practical discussion. I call it a discussion. Basically, I also have the same issue. Now, when you do buildings, you generally raise the ground floor at least 300 to 450 above the ground level. And newer lines are going below the existing ground level. So in that case, having a 300 to 450 beam should not be an issue.
Yeah. No, that's correct. Because if the building does not have a basement, very often that doesn't become an issue because you raise the building up. But if it has a basement, then what I said comes into the play. Because then the beam can be at ground level.
Yeah, I have another question that is
Yes,
not about structures. To these termite treatments, the termite say these ducts are the super highways for termites.
Yeah.
Because that is where the ground is bit, soggy, and also dampness is there, and they enter from those ducts.
Yeah.
Are you having any special detail to avoid this type of termite? Like, we always prefer physical barriers for termite than using treatments.
Yes. You are absolutely right, Nandana, because a good example is Galadari Hotel. 16 stories. Within 3 months of opening, we had termites on the rooftop floor. And that has a raft foundation, and the service ducts had concrete walls right round. In spite of all that, termites were found at the rooftop floor. That is an absolute possibility. But today, in the service duct, it is mandated that we provide what is called the fire stop at every floor level. So it has to be sealed mostly with concrete to prevent the propagation of fire inside service ducts, which have been found to be one of the major causes of fires in multi-story buildings. And if we do that, would it help in preventing the termites progressing up? Nandana?
Yeah, it will control to a great extent.
Yeah.
Yeah, and I think what you mentioned should I like to elaborate that when you do when you keep ducts in the buildings, generally we don't cut the reinforcement. We keep the reinforcements.
Yes.
I think this is for our structural engineers. So once the plumbing is done, you can reconcrete.
No, that is correct. That is how exactly it should be done, because the reinforcements are sufficiently widely spaced where we can locate our pipes within the reinforcements. And very often we don't cut the reinforcements at all, because you can position them, because now we know where the reinforcements are. And the reinforcement becomes an advantage when we had to do the fire stop. So that is absolutely correct. That is how it should be done. It must have the reinforcements in place, and which will be covered after the pipes are laid. Okay.
Yeah, while the questions are line up, I would like to again discuss about this the service facility under the slab. I think in most of the apartments, we prefer flat slabs.
Yeah.
Like, you know, having deep beams on the common wall is not a problem, because you generally don't cross your services to one apart to other one.
Yeah.
But within the apartment, if you have a flat slab arrangement, even with column heads, I think that is very a better solution for your MEP services.
Are you suggesting that we puncture through the slab and take it at the underside of the soffit?
No, I think dropping the slab is the best solution.
Yes, definitely.
But still, for other services, when you have a flat slab without beams within the apartment, you can run your other services, fire and fire without any problem. And you can even reduce the, you can increase the ceiling height as well.
Yes, correct. So that is why we have been using this, and it has been used very, very successfully, particularly in hotels, where the toilets are one above each other. So you hardly notice the drop slab.
Yeah.
Mr. Vijita.
Yes.
Yeah, Kamini again. So,
Yes,
Mr. Vijita, now as a whole, we have centralized sewer system in Colombo municipality only, as I believe. A little extension away from the limits also will be there, might be there. But the rest of the island, there is no such a facility in and all around this island.
No,
so
there is.
All our engineers, especially architects or whatever, keep in mind that our population entirely and as a general public always you come into a unbelievable situations like quarreling, fighting, sometimes fighting with the adjacent neighbors and all that. So my aim in actually organizing with you this QT session also to educate our people. We should not confine to design our elements. We must have a comprehensive dialogue and discussion with MEP services before finalizing our layouts. Not only come to design. So then, as engineers, we can always say we drive the nation. Otherwise, we are not driving the nation. We are giving some other people to come into and interfere with our services and our profession.
Gavin, you are absolutely right. But the only thing I would like to correct you, there are a couple of cities where there are central sewer systems. Kurunegala is one. Hikadu has a central sewer system now. There are a few others, one or two. But having said that, very often you have to have a local sewer treatment plant. Now, even for an apartment complex, a sewer treatment plant is mandatory now. UDA insists that each developer provides a sewer treatment plant. Now, you have seen how the multi-story apartment complexes are built virtually using the total land space. And one of the biggest problems is, where do we locate our sewer treatment plant? It needs space. It needs a lot of space to design something. So one option is to go underground, and that has an impact on the structure. So these will have to be coordinated at the beginning so that these can be integrated together, and the necessary, because it requires a lot of holding tanks. And as you quite rightly said, if we do that at the beginning, we both can survive. Otherwise, we will all perish.
I think Vijay, it is worth investing for central sewer systems, because you can charge from developers a reasonable amount, and providing a central sewer system.
Yeah.
I think one good example is a Pasikuda.
Yeah.
At the time of, I think, they introduced some system and they implemented it to at least to some extent. So, and major cities where a lot of apartment buildings are coming up, they always charge. The authorities locals are charging some money. I think they can charge a reasonable fee and invest for a central sewer system, which is really a big relief for the developers.
Definitely.
That is where we should, I think, advise.
Yes, Nandana, and that is also one of the best things that you can do for the environment. But having said that, Nandana, Pasikuda was not done by the local authority. It was only done by the tourist board. The same situation exists in Bentota and Hikadu. They have central sewer treatment plants done by the tourist board as an infrastructure facility, because those are planned tourist development areas. And that works extremely well. So much so that in Bentota, you buy back your treated water for watering your lawns and things like that. So it's an excellent system which is happening there.
Yeah, I think that can be used as a good model. Even the tourist board has taken a good step. Right. So why not other local?
It has been in existence for, I would say, well over 15 years.
15 years, yeah.
Yes, and it works. It works very well.
Yeah.
And it's very environmentally friendly and an excellent system.
Mr. Vijita, Ajit, speaking regarding the same treatment plant system.
Yeah.
Now, even the apartments and government is making mandatory to have the retreatment plants.
Yeah.
After the treatment also, then none has a solution to what to do how to handle the treated water.
You're very correct. You see, this is a very sad state of affairs in this country. If you look at the gazette for sewer and wastewater treatment, it starts off by mandatory conditions to be made for discharge of treated effluent to inland surface waters. That is what the gazette says. Or it says mandatory treatment standards for discharge into marine coastal waters. Right? Or it says mandatory treatment requirement for surface irrigation. Now, having said that, surface irrigation standard is the highest. Even if you do treat all your water to that level, which is very, very good quality water, this very same authority who published this gazette will not allow you to discharge into the inland surface water. You can't discharge it into the nearby drain. So this is a joke. But nobody says nothing about it. There is a standard for discharge into marine coastal waters, but you are not allowed to discharge into the sea. None of the hotels down south in the coastal areas are permitted to dump it into the sea, even after treatment. Now, Maldives have very strict controls and they allow you to discharge it back into the sea. So these are things what need to change. I don't know, but it's never been even openly discussed. You are very correct, because from these major apartments, which is having a very small footprint, when we do designs to get approval from environmental authority, we say the treated effluent is used for irrigation of the land and rooftop garden, because we have no space to show as land, because the building sits on the entire land. So it's a sad state of affairs. So they don't allow you to discharge it outdoors. You're correct. And these are the things what we will need to address and resolve.
And one other thing I want to highlight now, no, I think this is not regarding hotels, but when it comes to apartments,
Yeah.
we see most of the, like maybe not the high-end apartments, but I have seen experienced several apartments. The electrical, plumbing, those things are addressed.
Yeah.
But air condition provisions are kept, but that is only for electrical.
Yeah.
But the indoor-outdoor connections are not decided.
Yeah.
So finally, like everything becomes very ugly, and whose responsibility is, to keep that provision? Is it architects or MEPs?
Right.
Because why I asking this question is, the end of the day, structural engineer suffers because they are finally make some co-cuts in the beam and
correct. So you're correct. Now, I need to make a small correction. We should not use the term MEP because it has no meaning.
Right.
When you say MEP, it is mechanical, electrical, and plumbing. And plumbing is an integral part of mechanical. So it used to be M&E, but somebody coined this word MEP and it's being very often used. Pardon me for saying this, but it should be M&E, mechanical and electrical, right? Anyway, having said that, on this topic of provision for air conditioning, because most people do not provide air conditioners for these mid-level apartments or even top-end apartments. So what we do, wherever it is practically possible, we discuss this at the planning stages, because there are columns and beams which come in the way if you have to take your refrigerant piping out of the building. So that needs to be very, very carefully coordinated. We possibly could lay large diameter pipes to take these things out to predetermined locations and say your air conditioners can be only installed here and here. You have a clear path to take the pipes out. Sometimes we have even made provisions by way of sleeves in the beams after discussing with the structural consultants on predetermined identified locations. That's what it should be done. And the outdoor unit location must be predetermined and laid down in the planning stage. Otherwise, it will all hang like kajupulang all around the building.
So,
If there are no other questions, let us mark the conclusion of the session. On behalf of the Society of Structural Engineers Sri Lanka, I would like to thank Engineer Vijitha Pereira for the presentation, as well as the huge thank to all of our attendees for today's QT session. To deliver the vote of thanks, I would like to invite Engineer Nilan Hera. Over to you, sir.
Thank you, Prasanjit. Good evening to all engineers and invitees. On behalf of SSCSL, it gives me immense pleasure to deliver the vote of thanks. My special thanks to Engineer Vijit Pereira, to today's speaker, who delivered a valuable practical presentation. It's opened eye of all the structural engineers how to coordinate with the M&E works. And also I take immense pleasure to extend my thanks to our sponsor Lanka Group. Without them, this event may not be a reality. I also want extend my gratitude to Engineer Rama Vikrama, who coordinated the today's event, and Engineer Nandan Abesuri and all other EXCO members who give us a lot of supports. And also I thanks Associate Chapter of SSCSL, who host today's events, and always they support us to coordinate with the online events. And I also thanks SSCSL secretariats and all the today's participants. And thank you all very much, and we'll until we meet in next month. Thank you very much.
Thank you.